Hello everyone, today we will continue to go through the CKS question bank. Next, let's look at question 4. This question is about detection and isolation solutions. The main topic here is about accessing the mempod under our DV directory. This pod has exhibited improper behavior and poses a security threat to the system. So our main task here is related to the application. A pod has exhibited abnormal behavior by directly accessing the system memory and reading data from the sensitive file in the dev directory, specifically So, first of all, we need to be able to accurately identify the specific pod that is behaving improperly. Firstly, identify the misbehaving pod, and then scale the deployment of that particular misbehaving pod down to 0 replicas completely. In other words, this is equivalent to deleting all its pods. Setting the replicas to 0 essentially means the number of pods is reduced to 0. Even though the deployment still exists, in reality there are no pods running anymore. The main point to note here is that, apart from scaling down the replicas, we must not modify any other content of the deployment. This is a basic requirement. We are only allowed to change the number of replicas. Secondly, you cannot modify any other deployments. And finally, you must not delete any deployments. To put it simply, for this question, and actually for all the questions in our practice exercises, you are not allowed to do so. You must not delete any content unrelated to the current question. You should only operate on the content relevant to this specific question. Alright, next, let's take a look at how exactly we can find this pod and then completely delete it. As for the method of deletion here, it's actually not about directly deleting the pod with some command. Instead, we modify the information in the deployment and set the number of replicas to 0. This is the specified method, and other methods are not allowed. Everyone needs to pay close attention to this. Of course, deletion is definitely a method. There's no problem with that, right? We can delete, right? Delete the pod. However, in this case, the question does not allow us to simply do that. The question specifies a fixed solution, which is to set the number of replicas to 0. This is how we ultimately solve our problem. Alright, so here, let's first take a look. For this question, the main part actually needs to be handled in several steps. First, the first step. Because what is our pod right now? You could say it's unknown, it's uncertain. We need to detect it, right? To find the problematic pod container, right? Then it's easiest to delete it or set its replica count to 0. Either way works. So here, first, let's take it step by step. Let's find it first, right? Next, let's look at the specific solution to this problem.
If you want to learn Kubernetes technology or get the CKS question bank, please send me a private message. You can also leave a comment below the video to discuss technology.
Alright, so here, let's go into the virtual machine. The first step is, as always, to switch to the corresponding node. After switching nodes, we can start the actual operation. As mentioned in the question, right? Right now, we actually don't, right? Completely know where this pod is or who it is. So here, what do we need? We need to use commands to search for and identify which pod is having issues and then proceed to shut it down. Alright, so first, after we've switched into this environment, since this question also requires something, administrator privileges, right? We also need administrator privileges. So here, we also need to temporarily switch our permissions to administrator. Switch to SUI, then switch to our administrator privileges. Once the permissions are switched, what's next? First, let's check which deployments we currently have. What deployments are there? Let's press enter and take a look. Currently, we have GPU and CPU, so in total there are 3 items, right? 1 CPU and 2 GPU deployments. Alright, next, let's take another look. At the moment, there are 3 deployments, but we don't know which one it is. So, among these 3, one of them has an issue, there's a problem with it. So, what do we need to do when we come in? We need to create a security scan to find out where the problem is. Next, let's get started. The very first step to solving this problem is actually to create. Let's create it first. Let's create our scanning rule. With this scanning rule, we can help identify where the problem lies. Alright, next, let's go ahead and create the scanning rule. To create the scanning rule here, we need to edit the file under our etc. directory. It's a very specific rule file located under the main Falco directory, and the file name itself prominently starts with this particular prefix, subsequently followed by rules.local.yaml. Once we carefully enter and access this specific file, we can then proceed. After entering, you'll see it's empty by default. So what do we need to do? We need to edit some scanning information. We need to add a scanning rule. So for the first step, Let's start by using our dash list. Here, as you can see right now, we only have a single comment line. By default, it's just a comment. Whether you keep the comment or not doesn't really matter. It doesn't have any effect. What we mainly need to do is add the following content. So first, we need to use our list here. To meticulously create or precisely define a sensitive file to be carefully monitored. Here, after the term list, we strategically use a colon to clearly define our specific file. Specifically, which path should we write here? Let's write the one under the DV directory. Mem, which is the one mentioned in our question, right? So we've defined the sensitive file to be monitored. Now let's move on to the second step. Now we need to write the specific rules. Write the specific rules. After the colon, add dev. This name can be defined by yourself. Next, the main thing is to write out the specific details. For example, a description. The description here can also be customized. Yes, you can customize the description. This is basically about what we want to detect, what we need to monitor the MEM under DV, right? Monitor it. So what's next? Next, we'll add a specific detection item. A specific item, for example. We can utilize our file descriptor here to carefully monitor an access, to diligently monitor our access. As for the specific method that we will employ here, we can consider several approaches. First, we use our condition. Let's write this out first. Here, this is at the same level as the rules above. It's at the same indentation, so to speak. Here, this rule actually includes describe and description. These are basically just names or descriptions, and they're not the key information. The key information starts from this point. It starts from condition. After this content, that's where our specific detection content comes in. Only after this do we actually specify what to detect. So what are we detecting? We're detecting using this here. FTFD. FD here refers to our file descriptor. What are we checking? We're checking a file. So which file exactly are we checking? Here, you just write directly what we defined above. The name, right? In our first list, we defined M1M file, right? That's how we wrote it at the time. So here, it's actually just directly referencing the path mentioned above. By referencing that path, what we're really doing is monitoring the mem content under the DV directory. It's just that here, we're referencing the specific item we defined above. This sensitive file that we've defined, we're going to monitor it using this method. Now, when monitoring, what else do we need to do? We also need to capture a specific operation. So, for the operation that is being performed here, we are carefully using the output command to safely capture a potentially dangerous operation. At this specific position, you can simply press the enter key to smoothly continue with the process. Alright, at this point, let's continue writing our output. To capture the operation, add our specific content after output. As for the operation here, we're doing it through this one right here. Ensure indentation aligns with lines above, matching previous indentation. As for the specific operation here, what do we use? We use the container ID. So in the end, what we want to capture is the container ID. Ultimately, the key information we need is the container ID, right? That's what we want, the container ID. So for this ID here, we just write container here. Where do we put our container ID? Write it here. Of course, the first one here is basically a name, and the second one is something we need to use. It's kind of like a variable. Client.id. Alright, like this. The next two crucial points are actually about priority, specifically just the priority of the event itself. We absolutely need to change the priority setting of this particular event. For example, we should set its importance level to notice. This specific action ensures that our event can be properly and accurately recorded within the system. We simply just need to meticulously write down this information here in the designated field. So just set the priority to notice. As for this kind of tag, we just need to add a file. Just add a file tag. Alright, and after we finish writing this, this is our first and actually the most crucial scanning rule. Once we have the scanning rule, we can use it to scan for our actual real issues, pods with problems. So after identifying problematic pods, what can we do? We can simply shut down the corresponding deployment for that pod, right? That's basically the main situation for this question, the main scenario. So here, let's save it. Once that's done, we can start scanning. We can begin the scan. The way to scan is by using this. Because what we're actually doing here is essentially defining this file. What we've written is just this file. As for the time, let's just set it to 30 seconds. That's enough. 30 seconds is sufficient to scan and get the content we need. Then for the file part, we just add the path to the file we wrote earlier under or etc. or downloads. The file path we just used was rules.rlocal.ryml. Then, finally, the information we scan out can be saved into a file, for example, called dvmem, or just put into a log file. So we put it in here. Now let's run a scan. We'll scan for 30 seconds, and it will save the specific content into the log, as for the specific method, right? During the scanning process, we just need to wait a bit. Just wait for a moment. After the scanning process is completely finished, we can then check the final scan log to carefully review the content we specifically need. Let's patiently wait for a moment here. And after it's completely done, we can then use cat to view the log from devmem and carefully check the information inside. To find the specific container ID, you just need to run cat devmem.log and then press enter. Let's take a look. There's an ID, right? And the ID is fine, isn't it? Let's just copy this ID. Of course, actually, we don't really need to copy it, right? Here, we can actually just... For this part, everyone should pay attention, okay? For this part, if you encounter this during the exam, there might be a small issue here. That is, if you use the docker ps command, actually in the simulated environment, which command do we support? Mainly, it's the CRI-CTL command. And then for ps, we use it to filter. With this, you can query for specific information, but if you're in the exam, you can first use this one. Use the SIGTI command to query. If you get an error, what else can you do? You can also use docker ps, that's fine too. However, in our simulation environment, docker ps is not supported, so just use this command. During the exam, you can just use docker ps directly to check. Yeah, just use ps to check, that's enough. Once you've found it, what we ultimately need is just its final name, right? All we need is the name. So we just take this name. We need to move this name up a little bit. My head happens to be blocking it, but that's okay. It's right here, at this spot, right at the end. My head just happens to be covering it. Then, once we find it here, we just copy it. Who is this? This is a pod, this is a pod. So here, what are we actually looking at? We're looking at the container, and at the end, there's a pod name. There's a pod name at the end. So once we have successfully found it here, naturally, we can then proceed to use kubectl getPod, right? Let's take a moment to carefully look and observe. Who was it just now? Just now, it was this one. Who is it called? It's called CPU 77, right? Here, that's the second one, right? So the second one has a problem. Since there's a problem, we can just get rid of it, take it out. What's its name? As for the deployment name, it's actually very simple. It's just called CPU. So we'll take this CPU and just reset it to 0. The command to reset it is very simple. After that, the way to handle it is actually quite straightforward. Just directly modify the number of replicas. Here, actually, we don't need to go into the file, although editing the file is also a way. But in this case, using a command is very simple, right? Just change this option to 0. After changing it to 0, we can check again using our command. We can see that it's now 0 and 0. If you look at the other two GPUs, they're both 1, 1, right? But this one is 0 and 0. What does that mean? It means the number has now been reset to 0, which actually means we've successfully deleted it. This is a concrete example of handling a replica. This is a method for scaling down, a method for reducing. At this point, we've basically completed this problem. Here, you must pay attention. During the exam, after you find the name, right? Using pod. What do? Find our deployment and just set the current deployment to 0. This is the solution to our fourth question. This is how you solve question 4. All right, next up, let's take a closer look at question number 5. As for question 5, its content is actually relatively straightforward. It's about what? It's about a security context issue. Of course, the first step is still to switch to the corresponding host. Of course, in the previous question, because for question 4, since you switched twice, you need to press exit twice to return to your original location and then connect remotely again. Alright, so here the main point of this question is the requirement is that we must update an existing pod to ensure the immutability of our container. Then, the main task of the security context initializer is about, first we must update an existing pod, right? Modify the deployment named in our namespace. The deployment named SECDEP so that its container can meet what requirements? First, the user ID for our user should be set to 30,000 to 30,000. It should run using a read-only root file system and privilege escalation must be disabled. These are the only requirements. Essentially, this is about setting the security context for our user. The user ID should be 30,000, just 30,000. Here we can go to this path, right? Find our file. This file is the one we need to modify in this directory. Well, further study is also possible. The main point of this question is to modify a deployment configuration file to meet the requirements mentioned above. So that's the main purpose of this question. Next, let's take a closer look at how to solve it. Alright, first of all, make sure to switch to the correct specific context, right? Of course, for the previous question, make sure to exit twice. If you only exited once in the question before last, you'll definitely get errors when running commands later. Everyone needs to pay attention to this. Also, when you're working through the whole set, try to go through the questions one by one in order, because here, there are still some differences between the environment and CK. In CK, each part is completely independent, but in CKS there are certain connections between the questions, so you need to go through them one by one in order. Alright, next, let's take a look at question 5 and see how to solve it. That is, how to modify this deployment file. Alright, first, we need to use a command to connect to the corresponding node. After that, we can officially start making modifications. As we saw earlier, the question actually already provided us with the path to this deployment file, right? It's under the VM path. SEC, you can just complete the rest directly. Here, you just need to complete it after SEC. It's very simple. So first, let's enter this file, and once we're in, we can officially start modifying the file. It's actually quite large. It's actually quite long, almost a whole page. Here, the first thing we need to pay attention to is that the question gives us a total of 3 requirements, right? There are 3 requirements in total. So first, what is the first requirement? We need to make sure that the user can run it. This is a basic requirement, that the user can run it normally, that the user can operate it normally. Here, the user's ID is 30,000, right? The user's ID is 30,000. In other words, the user ID should be set to 30,000. So here, we can clearly see in the file, where can we specify the user? Alright, let's take a look and scroll down to the bottom. There's nothing below. This is the end. This is as far as it goes. Our file is just this long, exactly this much. Actually, there are 2 lines missing at the bottom. 2 lines that can't be displayed, but that's okay. It doesn't affect anything. This is our complete file, the whole file. So in this file, we can actually modify its contents. First of all, we need to make sure, right, that users can run it normally, right? Ensure that users can run it without issues. Here, the very first and most important thing that everyone should pay close attention to is that in the deployment field, actually not the deployment field itself, but rather the template field, specifically within the template section of the file. As you all undoubtedly know, a typical and standard file is usually divided into various distinct sections, right? SPC as well as our... Actually, there are mainly 3 parts. API version, right? Then K's metadata and SPC. So in total, there are 4 sections. In the SPC section below, this is where the specific description information is, right? Within the description, it's divided into post information, the number of pods, and so on. Then, along with the labels below and the specific pod template, actually starting from the deploy template section, that's where our actual pod information begins. Within this, we can see that metadata is still metadata, right? It binds the labels mentioned above. The most crucial information in the end is actually the spec section. In that section, the first thing we see is the container information. Within the container information, the first thing we notice is the name, right? The name. And the name here uses BusyBox. BusyBox. Actually, what we're using here is the smallest possible container, mainly for convenience in running things. BusyBox, for those who know about it, is not a fully fledged system. In fact, it has almost nothing inside. It can only simulate some commands. However, it can be used to simulate a container. using minimal resources to do so, which is very convenient. So here, first of all, what do we need to add here? Well, we need to add our user information. As you can see here, right, things like the container, the image inside the container, and the download policy, etc. Right, the mounted volume here, right? Below, these two names actually refer to two containers, right? The information for each container is basically the same, right? And below is the specific mounting information for our volume, and that's it. There's absolutely no user information. So in this file, what's missing is the user information. So what should we do? Well, we need to add user information in the container section, but where exactly do we add it? We need to find the right place below. For example, where can you put it? You can just put it under image. That's fine. Just put it under image. So what exactly are we adding? It's the information about our user. Because what we're essentially doing here is adding a user, right? Yes, we're basically adding a user. So here, we add our configuration after security, since this is about the security context. All right, so within this section, what can we start adding? For example, as we just mentioned, we can start adding things related to the user's ID, right? The user ID is 30,000. That's a requirement, isn't it? Yes, that's a requirement. Next, there's also the issue of permissions, right? Permissions. Here, what we need is, we need what? We need read-only access. This is mainly to achieve container immutability. So here, read-only means read-only, right? Read-only is read-only. Read-only. Add our root. File system refers to our file system. Root file system. Then for the next value, we need to set it to true, which means read-only. Secondly, we can specify the container's UID, which is our user. By running with this user 3000, the permissions are as we specified above. By mounting the container's root file system as read-only, we can achieve immutability for the container. Because if it can't be modified, then it's actually immutable, which could be... it could change. That's the second point. For the third point, finally, we just need to write prohibit processes inside the container from escalating privileges. So here, if you allow privilege escalation, that's allow, right? That means we permit privilege escalation. Allow privilege escalation. If you change it to false, then privilege escalation is not allowed. This is also a very important security switch, because even if the container is started as a non-root user, if this setting is allowed, processes could still find ways to escalate to the highest privileges. So if it's set to false, then it's much safer. This way, it ensures the effectiveness of the run as user setting above. So these three configurations here actually correspond to the three main requirements of our question, right? First, the run as user is set to 3000, right? This specifies that the user running inside the container inherits UID 3000, so this actually refers to the user. The actual username doesn't really matter, right? By using 3000, we've already fixed the user. This avoids running the container as the root user, which ensures the principle of least privilege for our container. The second point, right? Our read-only root file system means setting our root file system to read-only. This also ensures the immutability of our container. So what does this mainly prevent? If an attacker, right, exploits a vulnerability to attack the container, because our permissions are restricted, right, they actually have no way to modify or delete any files in the container's root file system. Because they don't have the necessary permissions, this can effectively prevent lateral movement and persistence of attacks. In this way, it relatively isolates and contains our risks. And the last point, right, is the same. Prohibit processes inside the container from escalating their privileges. We need to ensure the principle of least privilege. So these are the three things we need to modify. After making these changes, what do we do next? We must make sure, since these words are relatively long, right, there's actually something you need to pay attention to here. You don't just write it once, you need to write it twice. We need to copy this section. No need to write it again, just copy it, that's enough. Where do we copy it to, as we just mentioned, right? When we introduced the overall structure earlier, we said we have two containers. Since there are two containers, naturally we need to do it twice. Security settings, 2 rounds of security settings. Of course, copying here is a bit inconvenient, but that's okay. After copying, just move the earlier section to the front. Up to here is fine. So, this is our security measure. Both containers need these two security measures, since there are two containers. After we add this content under the image section for both containers, we save it, then exit. Next, we use Control to exit, and then redeploy our setup. We redeploy this content, redeploy these configurations. Let's wait a moment, then redeploy. After that, we can check whether our current status is normal. If everything is normal, we can exit. If not, it means there might be a mistake somewhere in your configuration. It means there might be a mistake somewhere. So here, let's check the specific information of our deployment. Alright, as you can see here, our current deployment, the status here is normal, right? It's normal. And let's also check the pods here. Right? No problem either. They're running, right? In the running state. So this is the main content of this question. Here, what you really need to pay attention to is that when modifying this question, you must remember, absolutely remember, to modify it twice. You have to remember to make 2 modifications, because there are 2 pods, actually 2 containers. I shouldn't call them 2 pods. To be precise, we have 2 containers. For both of these containers, we need to make modifications like this to ensure that our final result is correct, and that's all we need to do. We just need it to be stable and functioning properly. Here's our specific information, making sure that these people, these pods and deployments are all running normally. After that, what can we do? We can exit. Yes, we can stop here. Just exit using ESSD, and that's it for this part. That's the 5th question. As for the 4th and 5th questions, actually, overall, as long as you follow the requirements in the questions and make the necessary changes, the difficulty isn't really that high, right? These 2 questions aren't actually very difficult, and there isn't much to modify. For the previous question, it was basically about, so after scanning the content of a file, you find the corresponding pod and delete it. As for the 5th question, you need to update the pod information. Be sure to note that there are 2 containers, okay? So you need to modify it twice. All right, that's our 4th and 5th questions. That's all for today's content. Goodbye, everyone.